I was watching a talk of yours, and you were saying that there was some reporter who gave 3 titles to something of yours. One was that the man who blew up infinity, or something like that. And the second was the man who wants to rescue infinity. And you said that one was discarded, but it was just some internal title. And then the one that you said was more accurate, maybe not still entirely accurate, but more accurate. Harvey Friedman is about to bring incompleteness and infinity out of quarantine.
Right.
That's a nice one. Okay, so I want to ask you about the foundations of math. That's the theme that unifies this entire podcast between us. So the foundations of math. Suppose someone was to make a similarly sensational title. They could say, Harvey Friedman says the foundations of math are what? Like, are wrong, are broken, are not known, are not investigated enough, are what? Like,
are
what
totally up in the air, or are more mysterious than ever.
Okay, interesting. Okay, but that would be a correct encapsulation?
That's my view, yeah.
Okay, so then obviously someone's like, so what? Like, wait.
Okay, so
let me give you the analogy, because the analogy is, look, in physics, the people study the foundations of physics, and I'm terribly interested in that as well. But then the counter is, okay, yes, go, you few people, go about and study your foundations. I'm here building rockets. I'm here using quantum mechanics in the lab. Phones work, etc., etc. So I'm sure that's the sort of mentality that you see, that you encounter. So so what, Harvey?
Yeah. All right. So I'm trying to deal with that directly, but it took me 60 years to get to the place I'm at. So important, new, attractive mathematical subjects appear, depending upon what size you're talking about, appear regularly. People get excited about there's some surprising result and stuff they're familiar with, and then they want to probe more deeply and get a complete analysis of it, whatever. There are 2 concepts among the many fundamental concepts in mathematics. 2 of them are embedding and maximality. Both of them appear in undergraduate math and advanced math, in many themes, in many situations. And what I do now is do what I call embedded maximality. I say that these 2 concepts can be combined into new striking theorems. And I call the subject embedded maximality.
Mm-hmm.
This is the title of the book that I'm trying to finish. This is novel in the sense that 2 very basic concepts, which are generally not mixed, are suddenly mixed with some surprise, not just mixed. The context in which I do this is not arbitrary sets of real numbers. The context is the rational numbers with the ordering less than.
I subscribe to The Economist. Their science and their AI coverage is among the best I've found anywhere. And I say that as someone who reads plenty of it. I'll give you some examples. They just ran an analysis on how attitudes towards science are changing in American politics and what this means for research and funding in scientific institutions moving forward. This sort of high-quality reporting is fantastic. They even covered how dark energy may be weakening over time. Now, if that holds up, it completely changes our understanding of the universe's fate. If you watch this channel, those are exactly the kinds of questions that we explore every week. I subscribe to The Economist because their science and their AI reporting regularly surprises me with how deep it goes. And they're also, of course, known for global affairs, both political and economic reporting. They are top tier, and interestingly and flatteringly, TOE is one of the only podcasts that The Economist partners with. So as a listener, you get an exclusive 35% off. That's not a deal that they have just anywhere. Head to economist.com/TOE to subscribe. That's economist.com/TOE for 35% off.
So embedded maximality is the title of this book, and the context is among the most concrete situations in the whole of mathematics, which is simply the ordering of rational numbers. without even addition or multiplication. And I show that there's a finite theory of this where I look at all the finite embeddings that can be used for the maximality principle. And I analyze that first. And then I say, well, let's look at some very simple infinite maps, not just finite maps, but infinite maps within infinite domain.
Okay.
In the rationals, we're talking about, on an interval, it might be the identity on an interval is already infinite. All right. So, and then all of a sudden it completely explodes into beyond ZFC. Right there. So the plan is to define the subject very gently, called embedded maximality. Nice and friendly, simple definitions, half page to know what the subject is. State the finite theory, 30 or 40 pages of somewhat complicated stuff, completely analyzing the finite case. Attractive combinatorial mathematics of the kind that people have know and love. Nothing funny. And then say, well, I want to look at these finite maps on the rationals. I want to extend them by the identity map on the outer parts. In other words, if the finite function lives in here, let's extend it to be the identity above and below the function. That's a very simple kind of function, right? A very simple kind of infinite function. It's the identity almost everywhere, right? All of a sudden, you ask the same question: is this? Can you use these embeddings for the maximality principle? Can you use these embeddings? I solved it for the finite case completely, and the answer is it's independent of ZFC. That's the point of this book. So now it's harder for the mathematical community to ignore foundations. See, there's now this question of whether these theorems, there's a question of whether these theorems are in fact the outer extension usability theorem, OEU, the outer extension usability theorem. Is this a legitimate theorem of mathematics or not? Has this been proved? Well, we have a proof using some monster cardinals that go way beyond ZFC, and we know ZFC is nowhere near strong enough to prove it. So is this math legitimate? Has it been proven? It's like the old classic issue about, is it okay to use functions that aren't given by expressions? In the classical mathematics, everything is a formula or something.
Yes.
The notion of arbitrary function came up relatively late, as you know, and people were concerned about it, or even definition by cases originally. Because you have a discontinuity that's artificially put on, right? So,
I never heard of the definition by cases. What's that?
Definition by cases. F of x is 0 if x is negative. F of x is 5 if x is positive.
Yeah.
Something like that.
Yeah.
You see, that doesn't come from the old idea of formula. All right. So anyways, if in fact the mathematical community falls in love with embedded maximality, because I figure out how to say it and motivate it, and connect it, by the way, with standard mathematics, which I have a chapter on that, how to connect it up with semi-algebraic functions and piecewise linear function, the stuff that the bread and butter. I do connect it up with that, though when that connection is for background, I don't get independence from ZFC, but that it's so tightly motivated and clear, and the finite part is so interesting, allegedly, then one is compelled to take seriously the outer extension embedding theorem, which has been only proved using much more than ZFC and cannot be proved in ZFC. So this subject, embedded maximality, is drenched with ZFC incomplete. How the mathematical community will view this is not clear. I have to roll it out.